All right, welcome back. We're continuing on this program. We're going to go to version 2. So now we're going to version 2 of our program. So version major, minor. So version 2, a major change, right? Changing the functionality in a major way. And so let's do it. Now here's what we're going to do for this next part. We will come down here and we want to have a starting number that can be between 1 to 10, and we're going to have an ending number that can go, just for the sake of this demo, that can go from 10 to 100. So we want to prompt the user to enter those numbers. So a starting and an ending. So prompt the user for numbers. And then once we have those numbers, we want to use those, use the numbers to demo a for, a while, and a do while. All right, so that's our goal. Now, if we're going to have a starting and ending number, you could argue that these may change as time goes on, right? We may decide now we want to start, the starting number goes from 1 to 10 and the ending number goes, from 10 to 100, but we may change that. So what I'm going to do is come up here as another good example of using pound defines. Say pound define start number, I'll just call it start num min. This will be 1. And define start num max will be 10. And I'll define the end num min. Let's say it'll be 10. And define end num min or max will be 100. Now the advantage of putting these here is later on we could change our mind. Right, we just have to worry about the start number and the min and the max for both of these, and this gives us the ability to change. So anytime you find yourself, you could almost argue these are like configuration values. Anytime you have those, pound define is a good way to do that. Okay, so that's going to be our start, num, min, start, and end. So I'm going to scroll down and say, well, what I really want to do is have a starting number and an ending number, and I want the user to enter that. So let's have a integer, I'll call it the start number, and we're going to have an integer, the end number. Right, we're going to have two boxes, two variables that hold those. And we want to prompt the user to enter those numbers. Now, as I've said repeatedly, there's many different ways we could do this. I often choose ways that help explain and also review things we've already covered. So what I'm going to do for this one is say prompt for numbers. But I'm going to pass in a pointer to the start number and a pointer to the end number. Now this is important because what this says is we're going to write a function that will prompt the user for these numbers, and when the user enters those numbers, when we return from here, we will have the start and ending number having been entered by the user. By pointing to it, we're able to pass those results back. And in fact, to prove they come back, I'll do this. I'll say printf the start number is a %d \n, and we'll put the start number there. And then I'll do another printf and say the end number. This way we can confirm that we got what we were expecting. So %d, the end number. Alright. Now here's where I recommend you do a copy and paste, because we know this is a warning right now, right? It's green. So I'm going to copy this. Right, I've got that in my buffer. And then I'm going to go up before main, like go before our main, and I'm going to paste. And watch what I do. I remove the ending semicolon and put an open and close curly brace. And here I put a void, since this is not going to return a result. In other words, the function itself is not going to return a value, rather it's going to return the values that are in here. Now notice we're also getting errors here, because for the function we need to say we want to have an int pointer called start number and an int pointer called start number. Now I realize this is always a little confusing, but hopefully by me writing the code and you're watching, and we do this enough as we go through the course, it'll start becoming more clear. But how you read this is you say that start number, which we see as a parameter, right, an input. Start number is a pointer to an integer. Again, start number is a pointer to an integer. So that's the first parameter, and this is the second parameter. What this means is we can say, take the thing that start number points to, and let's set it equal to 1, 2, 3, and the thing that end number 4, 5, 6. Let's just do this as an initial test. This says if this is a pointer, we want to go to where it's at and basically put this value. In fact, watch when we run. I'll say yes, and look, we've got the start number is 1, 2, 3, and the end number is 4, 5, 6. Alright, so you may want to keep that. I'll comment it out. And remember, you can pause the videos. You can think about what's going on there. But what we want to do is prompt for the start number. So we'll say printf enter start number from %d to %d. Right, and I'm not going to put a new line. We want you to enter the start number from where? From the start number, start num min, and the start num max. Now what I'll do is, to make it line up a little better, you can put things on multiple lines because it's looking for the semicolon. So that'll prompt for that. And once it prompts, what we will do is our scanf, so scan function, and what we're scanning for is a %d. And where we want to put it is we want to put it in start number. Now notice start number is a pointer to an integer, and that's what this guy wants. The scanf is looking for he wants to know where, point to where I can put this at. Well, we're giving it the start number, so that'll take care of that one. And then I'll say if the start number that was entered, if it is less than start num min, so if it's less than that, Right, that's one condition. Or if start number, and actually I should be doing it like this if the thing is pointing to, if start number, basically the contents of what it's pointing to, if that is greater than the start num max. So if we have either one of those, and again I'll break it up here just to show you can do this. So here's one condition. If it's less than that, or if it's greater than that, and both of these, put an outside parentheses around both of these, because right, that's a condition. If that happens, then we need to tell the user the numbers are not in range. So what I'll do is say put string numbers not in range. All right, that's what I will do if that's the condition. And in fact, for this particular demonstration, there's various ways, but if you do that for this particular demonstration, we're going to say exit and say we'll say 1. Now notice when I say exit, this is going to exit the program, and it says it's implicitly declared. Okay, so that means we're missing a header file. Even though we're missing that header file though, let's test our code where it is right now. I encourage you to often test it. So notice this is a case where it gave us a warning, but even though it warned us, it also gave us a hint, said if we include standardlib.h, then we wouldn't be getting this error. So this is a way we can just exit the program. We say we're done. And in fact, I'll say, yes, enter the start number. Suppose I enter 700. Numbers not in range, exit status 1. Okay, so we got that. Now, it turns out we're going to do the exact same thing for the ending number. And one way I could do this, and I'll do it like this first, I could copy this and then just paste it right here. Because instead of the starting number, now I want to enter the end number. And instead of start num, I could do end num and end num. And again, be careful with copy and paste. You always got to make sure you get the values you're wanting, right? That after you copy and paste, you update everything. So now we want the end number greater than the end number min, and the end number greater than end num max. And if we have this one, I'll do 2. Notice I'm going to send a different error code. One error code will be if you did not enter the start number correctly. The other error code will be if you didn't enter the end code. Otherwise, we're all good. So this is a super important one. Remember, you can pause the video at any time. You can replay it. Let's run it. Oh, we still got this warning. Let's get rid of that. Let's do what it tells us to do. It says if you go up here and put an include standardlib.h. Okay, so we've put the standardlib.h. Now when I click stop and I click run, notice we don't get an error now. Okay, so let's see if our prompt for numbers works. I'll say the start number, I'll enter maybe a 5, and the ending number, maybe I'll enter a 50. Cool. Start number 5, ending number 50. So we got that. And I guess we'll go ahead, since we wanted to demo using the for and the while for each one of these. I'll say for integer I equals 0, I less than, we'll say actually let's do this, for I equal to the start number, for I less than the end number, and I plus plus. All right, so we'll increment each time. Let's just do a printf of %d. We won't even put a, well, maybe we'll put a space between it. And then we will say, give the value of I. So we'll do all that, and then we'll follow it by a printf with just a new line. So if I run this, and I say, how about we go from 5 to 15. So here we go, 5 to 15. We went all the way up, 5 to 15. And notice, for the sake of this one, I want to start at 5 and I want to end at 15. Well, notice this one ended at 14. Well, the reason it ended at 14, we said I is less than. Well, if we want it to end at 15, how about I less or equal? I less or equal. So we run this. Yes. 5, 15. Cool. We did our from 5 to 15. So that did it with the for loop. Let's now do it for the while loop. We could say, let's see, for the while loop, we'll say, remember we had this variable j, and j can equal to the start number. And then we could say while j is less or equal to the end number. And basically we want to do the same thing here. So I'll copy and paste. Remember, if I'm going too fast, you can slow down the video, and you can also pause the video. And this will be j instead of I. And of course we'll do j plus plus. So if we do this one, and I click on run, yes, 5, 15. Cool. We got this one. Probably should have put my final new line here. And then we could do the do while. So same thing, I'll say j equals start number. And I'll say do. And what I want to do is print out that I'll just copy this here. So we'll print that out, and we'll do that while the start number is less or equal to the end number. So 3 different ways, and we'll do our final printf here with the \n. Alright, let's run it. Yes, we want to continue. 5, 15. Whoa! This is what's called an endless loop. Now, when that happens, you can press Control-C or you can press on the stop button. You see why I wanted to put this here, because this is a case where we've made a logic error. You probably caught it while I was putting it in, but many times when you're working with loops, this is what happens. You'll get an endless loop. So you can see my problem is this condition will never change, right? The start number will always be less or equal to the ending number. So I wanted to show you what a so-called an infinite loop is. It would forevermore run this. So what we really meant to say is j, right, less or equal. So now when we run it, let me click on run again. Oh, let's see, maybe I need to clear my screen. Okay, let me do it again. So run, yes, 5, 15, cool, we got it. So version 2 of our program, we prompt the user and we show using, once we've prompted the user, we get the, use the for, the while, and the do while. We also got some good practice passing parameters to the function and back. This is a very important demonstration, this version 2, so definitely spend some time on it. I'm Norman McIntyre. Thanks for watching.